Okay, so when demand is relatively elastic, it basically means that there is relatively sensitive quantity is relatively sensitive to price changes, right? So, um, in fact, let me outline this a little bit more clearly. Um, Let me go back a slide here, a couple slides. Actually, let me go back to this equation here, right? So when demand is relatively elastic or responsive, it basically means that the percent change in quantity is bigger than the percent change in price, right? So let me switch over to my doc cam, right? So we've got price elasticity of demand is equal to percent change in quantity demanded divided by percent change in price. Okay, so when we talk about relatively elastic demand, it's because this is bigger than this, right? So relatively responsive, the percent change in quantity demanded is bigger than the percent change in quantity price, percent change in price. So let me just write that out here. Percent change in quantity demanded is greater than percent change in price. Okay, so when that happens, it basically means that demand is relatively elastic. Okay, elastic. Now, if this is true, I want you to ask yourself, if that's true, then what is going to be true about the value of ED, right? If the top of the fraction is bigger than the bottom, then what does that mean about the number ED, right? We know it's going to be negative because the law of demand, right? These things move in opposite directions. Price goes up, quantity goes down, and vice versa. So we know it's going to be negative. But what about the value of the number? What's going to be true about the value if this right here is true, right? If the top is bigger than the bottom. Well, if the top is bigger than the bottom, that basically means that ED, right, in absolute value, so ignoring the negative sign, is going to be bigger than 1, right? Okay, so basically, if the value of the number is bigger than 1, that basically means that we have relatively elastic demand, right? Now, the opposite of that would be if we switched this sign around, right? Let me just start over here. Get a new sheet of paper. I'll write this formula again just so we can see it. Okay, so there's our formula. What if instead the percent change in price is bigger than the percent change in quantity, right? So percent change in quantity demanded, that percent change is smaller than the percent change in price. Or in other words, the top is now smaller than the bottom. Well, of course, that means that the absolute value, ignoring the negative sign, of the price elasticity of demand is going to be less than 1, right? And when that happens, it basically means that we have relatively inelastic demand. Okay? So basically we have sort of a spectrum here. If you wanted to think about this in terms of a number line. So again, I'm ignoring the negative here, okay? So keep that in mind. I'm ignoring the negative. I'm just thinking about the magnitude. Oh, and by the way, the smallest this thing can be is 0, right? The biggest it could be is infinity, negative infinity, okay? But basically, if it's between 0 and 1, it means that the top is smaller than the bottom, right? So the response is pretty small. The change in quantity demanded, the response in quantity demanded is relatively small compared to the change in price. And so if that's the case, ED, elasticity of demand, falls somewhere in this region. And if the number is in this region, that basically means we have inelastic demand. Okay. Another way that is helpful, I've found, to think about this is a bounded region, right? It's constrained. there's limits on it. So in that sense, it's inelastic too. It can't be very flexible if it's sort of trapped in this range. Whereas in this range here, 1 to infinity, that's unbounded, right? Unconstrained. In other words, it can be very responsive. So that might help you remember this. But this region is the elastic region. Okay. And then there's actually, we have a name for when it's exactly equal to 1. That's called unit elastic demand. Okay. Unit meaning 1. Okay. So if it's exactly equal to 1, it's called unit elastic. It's neither inelastic nor elastic. It's unit elastic. Okay. All right. Let me get back to where we were in the slides. Okay. So that's what we were talking about here. Now, we can relate these things to the slope of the demand curve. Okay. So when demand is relatively elastic, it basically means that it's closer, it's flatter. It's going to be more horizontal. Whereas if demand is more inelastic, it's going to be steeper, closer to vertical. Okay, so we can relate elasticity to slope, although they are not identical. They're not the same thing, but they are related. Elasticity and slope are related, and they are related in this manner. Okay, so let's see what that looks like graphically. So here we see a perfectly vertical demand curve. Okay, so we can see that given any price change, there's absolutely no change in quantity demanded given a vertical demand curve. So basically what that means in terms of our formula, it means that the numerator is 0. So our elasticity of demand is 0. Okay, so looking over here back to our number line right here. So this is a vertical demand curve. And we can call this perfectly inelastic. Okay, can't get any more inelastic than that, right? Absolutely no response to the price change. Quantity stays exactly the same, and that's for any price change. Okay, so it's perfectly inelastic. Okay. Now, as we start to rotate our demand curve, going from perfectly vertical, start rotating it. Let's see if I can do this right. Start rotating it this way. It's getting flatter, right? So we're getting more elastic as it starts to get flatter. But here we still have relatively inelastic, right? Because the percent change in quantity demanded is small compared to the percent change in price. And so we end up somewhere in this region between 0 and 1 for our fraction. Okay, so but then as we get even flatter, we get more elastic. So now we have entered the relatively elastic range where the percent change in quantity demanded is big compared to the percent change in price, and so our fraction is something bigger than 1 in absolute value. So we've entered that elastic range. And then the other extreme is perfectly flat, a horizontal demand curve. Okay, so this is maybe a little bit harder to think about, but this is basically when given even a very small change in price, we have basically an infinite change in quantity demanded. And unfortunately, I don't have a dollar bill on me, but I usually use a dollar bill in class to illustrate something that's perfectly elastic. Okay, so I will mention that this is the other end of the spectrum here, right? That when the elasticity is negative infinity, this is called perfectly elastic. Okay. But I usually use a dollar bill to illustrate something that is perfectly elastic. So think about this. If I were to say, I'm going to sell you a dollar bill for 99 cents. Actually, let me start with a different price. Suppose I was going to sell you a dollar bill for $1.01. How many would you buy? Well, hopefully you would say, I'm not going to buy any from you because every time I buy $1 from you, I'm going to lose a penny. and I'm not interested in losing money, right? So if I charged you $1.01 for a dollar bill, you would buy 0. But if I changed the price just a very tiny amount to 99 cents, you would buy as many dollar bills as you could. In fact, you would buy infinite, because every time you buy one, you would earn a penny. Okay, so this is an example of something that is actually perfectly perfectly elastic. But this is basically what it would look like graphically. It'd be a horizontal line, and the elasticity would be negative infinity, so perfectly elastic. So just to summarize all of that, as the demand curve gets flatter, it becomes more elastic, and as the demand curve gets steeper, it becomes more inelastic. So again, slope and elasticity are not the same, but they are related, right? And in fact, with a linear demand curve, which are the only types of demand curves, the only types of demand curves that we will see in this class, the slope, just to illustrate this, right? Let me even draw this for you. All right. Let's see, make sure I'm in view. So for a linear demand curve, think about what the slope is along a linear demand curve. The slope is the same along all points, right? As it turns out, the elasticity will be different at every single point. So this is illustrating the fact that they are not the same. They are related, though. And as it turns out, the point right in the middle, right? If we were to find the point exactly in the middle between the two axes, that turns out to be the unit elastic point. Okay, and then anything above that is a relatively elastic. So this is the elastic region, and then anything below that unit elastic point is the inelastic region. Okay. Now the reason for that is because in this region, right, prices are relatively high, right? Just in this region, let me just pick a point in that region. Prices are relatively high compared to quantities. Okay, so the reference point for your quantity is relatively small, and the reference point for your prices is pretty high. And because of that, the numerator is going to end up being larger than the denominator, and so you get an elasticity that's greater than 1. Whereas in this region, price is relatively small compared to quantity, and so the numerator ends up being smaller than the denominator, and you get a value of something less than 1, and so you're in the inelastic region. But you don't really need to know that, I guess, but hopefully that helps you understand why that's the case. Okay. So in other words, to wrap this up, to summarize this, as we move down the demand curve, things become less elastic or more inelastic, right? Okay, so there's another nice picture for you. This is actually a good, you could use this picture as an exercise to practice calculating elasticities using the midpoint method, and also to prove to yourself that this is true, that as we move down the demand curve, it becomes less elastic. So I would encourage you to do that. Pause the video if you need to do that.